FDP session, FDP on AI-driven embedded product development. We are happy to have you here. So we'll wait for 2 more minutes. In meanwhile, our remaining faculty member will join. Meanwhile, I request our resource person to address the yesterday's doubts. Mr. Sai Shankar, please go ahead for the doubt session.
Hi, good afternoon, faculties. If anyone is having any doubts, we can discuss until 7:35. In meanwhile, other faculties will also be joined. If you have any doubts, you can drop it in the chat box or you can speak it also.
Good evening, sir.
Yeah, good evening, sir.
Sir, yesterday I'm asking that Altera related details.
RTM related, yes.
Yes, sir.
Yeah.
How to get it the license and
Yeah. Actually, there is some mail ID from RTM. Just a second, I will look and I will drop it in the.
Guys, regarding yesterday's previous recording sessions and as well as learning resource material, we have already shared through mail. Please check it once. If you don't get those things, please let us know. I'll check with my team, technical team. As of now, we have shared the recording session as well as learning resources. Please check your mail.
I got it, sir. Everything I got it. I checked it today. Recording section and PPT also I'm got it, sir, today morning. I'll check.
Yeah. Thank you so much. If anyone doesn't get those things, please let us know.
And I just have dropped the link for the RTM student registration. If faculties can share those links to the students, they can enroll into that website and they, based on that, they will get their licenses for
Okay.
6 months or 1 year based on the college capacity, and they will basically contact with the colleges and they will provide the licenses.
Okay, sir. Okay, sir. Thank you.
Apart from this, does anyone having any doubts relevant to the yesterday's session or something? Okay, then today we will jump into our main session, where today we will be looking into the hardware and schematic design of the PCB layout. Okay, and we will be covering the topics or the main relevant information related to the PCBs and unknown variable related information, and we will be designing our first schematic today in easy EDA, how to draw that and how to check that. Okay, today's majorly we are seeing the PCB terminologies and hands-on design a simple circuit in easy EDA, and AI assisted PCB design review and validations also we will be looking into. Mainly PCB terminologies. The first terminology we will call it as in footprint. Yesterday we have seen the terminologies relevant to the schematic, like what is meant by symbol and what is meant by majorly this is called the footprint. Footprint is a physical layout of pads, outlines and marking on a board that matches a component physical dimensions and pin configurations. It ensures components are correctly placed and soldered and helps with routing and spacing between the components. You can check here these U1 is the component nomenclature, and these pads and everything all together of a complete IC is called footprint. That is the similar way it is having for C. C is nothing but for capacitor, R is for resistor. In similar way, these things are called footprints. And traces, another major terminology. Traces refers to a conductive path that carries electrical signals and power between the components. These traces are essential section of copper foil that remain after the etching process, creating a network of connections on the board. They are crucial for the proper functioning of the electronic circuits by facilitating the flow of electricity. You can see this is nothing but a trace where it establishes the connection from point to point. Yeah, ideally we are having two other terminologies with respect to the trace. One is trace width, another one is trace spacing. Trace width is nothing but the physical dimension of the trace. Trace spacing is the space between each trace. Here the trace space will be helpful for the isolation purpose. Trace width will be helpful for the increasing the current conductivity flow in the trace or particular track. We will call trace or track. Both of them will be same. And while coming to meant by what is meant by track, with ideally when we are seeing any conductive wires, uh, all of them will be in the circular model. But ideally when we are doing in PCB, those will be not in the circular manner, those will be in the rectangular fashion. So they that will be having track thickness as well as track width. This track width will be helpful to decide the flow of current within the PCB. So based on the requirement of current flow, we will be deciding the track width on the PCBs. Okay. Ideally, we will call the track widths in mils and track thickness in the microns or in the ounces. Okay. Ideally, the standard is 35 microns or 70 microns. 35 microns is nothing but 1 ounce and 70 microns is nothing but 2 ounce. Where track width will be measured with respect to using mils. 6 mil, 9 mil, 16 mil. Those are different kind of standards. So ideally, we will use in the um, industries. And track width refers to the physical width of a conductive path on a board, which are typically made of copper, or there might be an aluminum or gold also based on the PCB type. And track width significantly impact a PCB ability to carry its current and controls the impedance also. Okay. And adequate trace width is crucial to prevent overheating and ensure signal integrity of the PCB also. And next terminology is nothing but via. Ideally, via is kind of in making a connection between two layers, either top or bottom layer or in between any layers. There will be two kind of vias. One is open via and a filled via. Open via is nothing but there will be an open slot on a PCB to see the hole, as well as in a closed or filled via, the via will be there, but this filling section will be filled with an insulation material to avoid the corrosion as well as to avoid the uh, issues when we are handling a multi-layer PCB. In a multi-layer PCB, ideally we will be using filled vias within and between the traces, between the layers, and based on the requirement, we will be going to the open vias. It is a kind of a small drill hole which goes through multiple layers to make a connection between multiple layers. Okay. And coming to the next section, that is pad. Pad is nothing but exposed region of a metal on a circuit board that the component lead is soldered to, or multiple pads in conjunction are used to generate the component footprint. Okay. Or land pattern on the PCB. The two types of pads available are through hole and surface mounted pads. These are called surface mounted pads, and coming to through hole pads are nothing but these pads are called through hole pads, where the component will be soldered opposite side of the PCB. And in the surface mounted or SMD technology, the soldering will be happen on the top of the PCB itself after placing a component. And this is called copper pour. Copper pour, don't worry, when we are dealing with a layout designing, I will explain regarding the copper pour, because a lot of people will get confused what is meant by copper pour. Just right now listen what is meant by copper pour, and when we are dealing with a routing, then you will get full clarity on what is meant by copper pour. Copper pour refers to the technology or filling unused areas of PCB copper layer areas with solid copper planes, either VCC or ground. These planes connected to power or ground via using VSS or through hole connections. Okay. Basically, these are used to provide strong ground connections as well as for EMI EMC protection circuits also. And silk screen or legending screen is nothing but a white text and lines that ideally we will see on the PCBs. Na? That is called silk screen. This IC1, 0.1 MUF, all of these information what we are seeing on a PCB is called silk screen. Okay. And soldering mask. A solder mask, also known as solder resistant, it protects layers applied to the PCB to prevent solder from spreading to areas where it is kind of, let us say, see, this section is called shoulder mask. By providing this mask, this lid will not overflow or make any connection from point to point. Just to prevent this lead overflow, we will keep this shoulder mask. This shoulder mask, silk screen, all of these are main layers within PCB routing or design when we are dealing with. Planes are nothing but in copper planes are layer. Here we are having 4-layer PCB or 4 planes PCB. One is on the top, another one is on the bottom, and there are 2 middle layers. Is nothing but power plane, ground plane on top layer and bottom layer. Ideally, why we will call it as in planes, because complete layer of this PCB is having only one connection. Either it will be on VCC or either it will be on ground. So we will call it as a plane. It is a simple complete copper area, and to establish connection from component to component, we will use YSS here. And this is called clearance. Clearance is the minimum distance required between two conductive paths. So it will prevent the shorts as well as arcings and other issues on the PCB. Which this is one track, this is one track, and in between both of these called clearance. And PCB outline. PCB outline is a border outline of the PCB which defines the physical shape of the PCB. It is enclosed, it might be enclosed polygon, it might be in any circle. Based on our requirements, we will be designing or finalizing our PCB outline. So by that, the PCB routing space will be limited. Based on our mechanical constraints, we will be considering the PCB outlines. But always it should be a closed circuit. And PCB stencils. Stencil is typically a thin sheet of stainless steel with openings that are generally laser cut and is used for application of soldering paste. Ideally, if this stencil will help in the production process. When we are designing a PCB and it comes to a production phase, when we want to solder the components on a PCB, we will need to apply the soldering paste on the PCB. Manually applying a solder paste on a PCB, it is very difficult. So we will place the PCB beneath the stencil plates and we will pass through the soldering paste on top of that. So like how in the traditional way, we are keeping our sari, the dresses or saris were printed, like there will be a printing machine on printing cloth on top and they will apply the color and they will mask it. In similar way, the stencil will also apply the paste, soldering paste on the PCB by using the stencil. And etching. Etching is a main process in the PCB manufacturing and in the fabrication process, where to remove the unwanted copper on the PCB and to provide only required copper area on the PCB or conductive path on the PCB. Ideally, there will be two type of holes on a PCB. One is PTH and another one is NPTH. PTH is nothing but an via kind of plated through hole, and NPTH is nothing but non-plated through hole. On a PCB, if you want to keep a hole, you can keep it in the both the ways. By using plated mechanism, nothing looks like a via. It can be a via or it can be a just plated thing just to useful for the soldering purpose. The NPTH is just for a mechanical support. We will ideally keep it. It does not have any electrical conductivity path. Like how we discussed in the vias in the multi-layer, this is how the vias will be looking, which provides the electrical connectivity. And these are called slots. Looks like via, but these are not perfect circular, and these are kind of eclipse shape. But as per our industrial standards, we will in the PCB design we will call it as slots. And for this, there will be a different kind of drilling mechanism too. And in PCB, we will having an effect called crosstalk. Crosstalk on a PCB is nothing but, let us say this is one track and this is one track. Because of the current flow in one section or a signal flow in one track may have mutual induction effect on another track, which will have impact or noise effect on the other signal. That is nothing but a crosstalk. Ideally, you can see here on the left side of your picture, C to D, there is a signal passing a pure square waveform. Because of an parasitic capacitance on a PCB, which is CSV, has a mutual induction effect on a track from A to B, where you can see the spikes on the track, which is having the crosstalk effect. Okay, when we are dealing or designing very high speed signals or over current signals, we should keep that in our mind. To avoid this crosstalk, we have to maintain a higher the track with gaps. By providing a higher track with gaps, we can avoid these crosstalks also. And we will see today how to design our first schematic in easy EDA by using a standard library symbols. Further going ahead, we will create our own symbols and we will create our own footprints and we will design everything from scratch to uh, industry level. Okay. First, we will create a new project in easy EDA and start a new schematic project. And we will add components, use the components library to place a microcontroller, a power supply, sensors, whatever needed to be. Connect the components with wires, uses labeled connections instead of cross-talking wires, and assign appropriate power supply connections. Set the values and footprints, specific resistor values, capacitor ratings, and IC footprints, and so on and so forth. And run the real check like ERC electrical check rule checks. And below is a kind of a sample circuitry where it is having a battery and one resistor and an LED, nothing but in diode. We will be drafting our first schematic and we will be designing our first PCB, how it looks like and how we will convert it into an layout. Also, we will be looking by placing it strategically, arranging the components and making an routing, and we will see how it will be looks in 3D design also. Okay. Post the live session, we will be looking into the AI assistance in the PCB design overview. For time being, I am switching my screen to easy EDA. If you guys want to follow also, you can also follow. You can go to easy EDA. If you guys want to follow also, you can also do the same along with me in your pieces. Are you guys also willing to follow with me right now, or should I say it in fast phase so you will see it and practice it on your own? Okay, right now I am going to explain
Sir,
how
once
to
again, tell me that name. Easy.
easy EDA. You can
Easy
see
EDA.
on
Okay.
the you can see it on the screen. This is the website easy EDA. I will be explaining step by step, no problem. We have
Okay,
time.
sir.
Yeah, just go into your browsers and enter easy EDA. After going to here, instead of downloading the application into your PC, you can click on design online and go to pro edition. Ideally, this is how the base page or the open page will looks like. After going to here, just click on the login or register if you are very new guy. Ideally, every faculty might new to this account. Give your email credentials here, or you can simply by clicking on sign in with Google, you can directly jump into the sign in also. Give your mail credentials and enter into the main page where it is having lot of workspace. Inside here, it will be showing all the projects relevant to your workspace and common libraries, what all the available here. These are the major section in the workspace, and it is having a lot of options here like new project or opening project and other stuff. This section is called the complete library section, where it is having devices information, footprint information, 3D models and all the stuff information. This is information block. If we click on any component, it will provide its symbol, its footprint, and its 3D view and every information relevant to here. And this online chart is nothing but a chart bot. By using this, we can get our things easy to done, kind of by using AI technology too. For time being, we will be creating a new project. Here, even though, as I said yesterday, even though if you have a schematic from other sources, like by having a schematic in Altium or KiCad, you can import those schematics here and you can do your stuff, or you can export your schematics if you have done it in the easy EDA too. Yeah. For time being, we will be seeing a and you can give the owner name, project name, and description if any, and you can click save. If you want to create a team with multiple people also, where you multiple people want to work on a same project also, you can create a teams over there. Okay. After creating a project, it will be creating in two sheets. One is schematic, another one is in PCB.
Sir, hello, sir. Hello,
Yes, yes, sir.
sir. Tell me
Yes, sir.
slowly,
Yes,
sir.
sir.
Tell me once again, sir.
Oh,
Slowly.
okay, okay, sir. No problem, no problem. I will be explaining. Yeah. I will explain once again from the starting. After opening the easy EDA, click on that Pro Edition. After clicking on this Pro Edition, you need to go, or you need to log in here on the right side. I have already logged in. I will log out and I will show how the login will looks like. This is how the login looks like on the top right corner. Okay.
Okay,
Just
sir.
click on the login
Okay.
and simply by using your mail ID or Gmail ID, you
Okay.
can sign into your Gmail. Yeah. It might take little bit time. I will wait and let me know if everyone is in this place or at this space at this point. I will continue further how to create a project. Okay. I think everyone can able to log in. Okay. After logging in, this is the place where our workspace related information will be there. All the new projects or all the your existing previous projects will be, you can see it here or you can access it from here. Okay. And this is the common library path where you will be finding where you will be finding all the schematics, PCBs related symbols and every stuff. And relevant to the same common library, this is the online library where you will be finding the capacitors, connectors, all the kind of components here. And this is the information place. Let us say if you click on any connector or something, it will give its symbol, footprint, and a 3D view of that particular component. And this is a quick start area where you can find, create a new project, or you can open a project, you can create a new component, new footprint, or 3D model, whatever you want, or you can use it to. You can also import the schematics if you have a schematics in Altium or in KiCad. If you want to design only routing layout section, you can also use easy EDA just by importing Altium or KiCad designs too. Okay. For time being, today we are creating our new project, like we can give the name as our wish. Here, when we are creating the project, it is mandatory to give a project name, the owner. Ideally, you will be the owner for your project. You can also create a team, like if two or more than one, if more than two people if want to work on the same PCB or on the same project, they can create as a team and they both can work one on another. So basically, this is a cloud-based mechanism. So both will have access. No need to share the files one after another. So that is a major advantage here. And it is having a project link or the repository where you wanted to. And this is the description. If you want to give a detailed description, you can give the description here also. By clicking on save, where it was loading now, currently you can see, it will create a project with a given project folder name, and it has one board. Under that board, it is having one schematic as well as PCB design also. Okay. In the schematic, you see, this is the basic schematic sheet. In the schematic sheet, it will be having an outer boundary outline as well as nameplate details of the schematic also. Here we will be having the here we will be having the schematic name, created date, updated date, board name, page, and drawn by, reviewed by, and the project name related, version, size, and the related information. You can change this easy EDA with your company logo or your college logo, however you wish to. As we are the faculties or the students might not need to address this clearly, but when we are dealing with an industry level designs or when we are doing everything as per process with respect to ISO standards, we need to follow these also particularly, because ideally when we are in college we might deal with one or two projects, but in real time there will be plenty of projects and that need to be tracked along with the dates as well as who is drawn and who is reviewed by also. To track all of such kind of information, this nameplate details will be so helpful. Okay. For time being, we will be draft a small circuit. You can see or you can follow it later by seeing a video. Yeah, simply by clicking or selecting LCSC Electronics, which is an online library, and by giving the appropriate or required manufacturer part number or description of the component, by clicking enter on the module, you will find all the relevant information. Why I am not able to get the battery? See, we will use an coil cell battery symbol. We will be placing it on the PCB. Simply by clicking on the place, you will be getting the symbol, and you can click on the schematic sheet, and it will be placed on the PCB. Sorry, on the schematic symbol. And in similar way, you can bring the resistor. Time being, we are using some random value, and further going ahead when you are dealing with a real time thing, you can actually choose the resistor or manufacturer part number as per your convenience. Further going ahead when we are discussing regarding the BOM and every stuff, then you will be understanding what is meant by manufacturer number, MPN or manufacturer part number, and how to select them. This is how we can place the components on the schematic sheet, but you can see all of the symbols are placed on the schematic sheet, but none of them electrically connected. So you can click on the component. By clicking on a space bar, you can rotate the module as per your convenient. And here there will be a connection for making the connections called wire on top of the PCB. You can see which is here wire. Or otherwise, by simply clicking Alt plus W also, wire options will be you can drag. You can connect the connections from point to point where in this way, like how I am showing now. This is how the wiring will be happen. In the beginners, lot of people will do the mistake, like I will show how the basically lot of people will do the mistake. You need to connect the wire from this dot point to this dot point. Lot of people will get confused and try to connect from here. And right now this Pro edition will give proper access and will make a connections. But sometimes if you try to connect from center point, it might can't able to give connections properly. Keep that in mind and make the connections accordingly. Okay, this is how the basic schematic you will make the connections. Further going ahead, in the last date we will be creating an actual real-time project. For understanding purpose, I have given this as a demo. You guys need to follow on this and you have to practice by your own. And when coming for tomorrow, you need to do your own project. And if you have any, if you are facing any doubts, we will discuss on that front also. And after doing this schematic, we will be converting this into a PCB. Here on the top of the section, you can see there will be a lot of options like file, edit, view, place, design, and so on and so forth. Here in the design, we will be converting or update the schematic into the PCB. By clicking on here, the schematic section will be converted into a PCB section. Like it will import all the components, which is LED, resistor, and U1 component is nothing but a battery holder. Everything will be come here. By clicking on apply changes, everything will be reflected here. The first and foremost thing, before placing of anything, we have to give the outline of the PCB as we have discussed. This is the place which is called board outline. You can see here on this section on the tab, you will be having a lot of sections like rectangle, circle, or polygon, however you wish to. As of right now, we have selected a rectangle. After selecting this component as a rectangle, we have to always keep it in the closed section and we can place the components however we wish to. Currently, we are designing the PCB or the circuit for we are keeping all the components in only single layer. When we are dealing with a real-time project, we will be seeing how to do it in place the component in multi-layer also, or you can try it on your own. And if you are facing any difficulties, we can discuss them in tomorrow's session. And this is how we will optimize the positioning of the PCB. And if we are overcrossing outer boundary limits, you can see there is an error mark here. Always the components or the footprints within the PCB should be inside this boundary outline. Okay, after placing the components, similarly how we have make the connections in schematic, we have to make the routing also. Here by clicking on route here, you can create the routing sections. Okay, simply you can connect the components like how it is should connect it to on the PCB. When we are doing the routing, you can check which is on your top layer, and this is the line width is nothing but a track width, and it is giving all the relevant information also here. Where this is the PCB, how it looks like. If you want to check how it looks in the 3D, by clicking it on 3D, this is how the PCB looks like. Okay, all of this is the basic how we will design the basic schematic and basic layout part. Might be I have explained in fast phase. You can go through the video and you can able to understand and you can able to grasp the session and try to practice on with your own hand, and we can discuss the doubts related to it in the tomorrow session also. And if you guys are having any doubts until now, you can also ask the doubts relevant to that. And after that, we will be discussing related to the AI enhancements with respect to this design, how it is happening and how it is going to there. Okay, first we will discuss regarding the doubts, and I will also explain regarding the AI stuff later if you have anything. Okay, if there is no doubts related to the PCB as of currently, I will be sir, how can this software design integrates into hardware? So this is the part how we will design the basic PCB and schematic. And further going ahead, I will explain how to generate a Gerber and how we need to send to the fabricator, and how can we get the real PCB also. I will explain in the further coming days. And coming back to the AI assisted PCB design reviews and validations with respect to schematic and PCB reviews and validations. Ideally, by giving the schematics and the prompts has in the chat GPT or in the Gemini, which detects the missing bypass capacitors on the IC spin levels, and it will give recommendations for the capacitor values from the specs as well as the frequencies. You can also check on the right side, there is a data sheet attached for a part number of AMS 1117 is kind of a regulator, LDO regulator, low dropout regulator, where it requires few capacitors and few power supply regulators need to be taken care. So if we pass the data sheet and if you ask for the recommendations, it by studying the complete data sheet of a module, and it will give the suggestions and recommendations. Or if you give the schematic and the data sheet of a particular thing, it will suggest and it will give the flaws in our design, which verifies the regulator input output kind of bulk or capacitors and it will also flags missing components in the PCB, where it will be helps us in creating a new design if we are so fresher, as well as it will be helps us as a reviewer or quality inspection engineer also. This is how in LDO, as we discussed, which maps the schematic next to datasets, pin table to verify pin level correctness, analyze signal names, polarities, and detects the swap TXRX for the differential pair signals. And it will also give suggestions like where to connect and what need to be connected. Like you can check on the left side of the PCB. This is how it is generated a real-time schematic. Based on this, we have to draw it manually. Currently, there are a lot of other technologies which adopting AI internally, where it can automatically generate schematic completely. But currently, there is no such kind of ready-made tool available in the market for free of license, and which learns the standard bus wiring patterns for SDSCL or SPI misconnections, kind of a serial communication interface. When we are discussing with respect to embedded, you guys will get very clarity on what is meant by SPI, I2C, and a lot of other stuff. And it will give the references for the oscillators, and a lot of other validations can also done by using this AI currently in the market. Like it will automatically detects the floating pins or open connections. Sometimes when we are designing or discussing with very big project, let us say, which is of very huge PCB, which is having 200 to 500 number of components, then when we are designing, we might miss few of the components when we, or otherwise we might left the floating connection also. In such scenarios where this chart bots will help us to identify those floating pins or unconnected connections, and it will also flag us related to where should we connect the pull-ups pull down resistors for the suitable logic level implementations. Okay, you can go through the PPT in detail for each and every point, and you can get understand it even better. And it is right now, as we have discussed, it is having power integrity and voltage validations also. Kind of we can simulate the circuit, or we can test the circuit in the PCB before generating into PCB level. So it will give us lot of time as well as a cost advantage, while we can simulate lot of stuff here, which checks the current capacity of a component as well as stress factor on a component. Such kind of things can be simulated also. Okay. Here is first level reviewer in the design validation, like how we have discussed. Like it will automatically first pass the design, and it will review each and every point, and it will give suggestions, it will give errors within the design, and which it will be helps us to do the documentation for that generated reports if everything is fine. In such kind of scenarios, right now AI is helping us in the industries. That is for today's session, guys. Thank you. And if anyone is having any doubt relevant to today's session, or any part you guys are kind of missing when I am presenting it in the live demonstration, I will once again represent that, or once again I will give the live demonstration if you guys want, or otherwise there is nothing, you can leave the group also. AI has reduced the design burden I believe that it is also has affect the technical expertise of designers. Europe. Yes, ma'am. Like always, I will say to my juniors, like in very olden days, before we are having smart mobiles, there used to be landlines with us. So in that case, when we wanted to store the mobile numbers or contact numbers of our family members or the relatives, we use it to write it in our notes. Or lot of people can able to remember their contact numbers within their mind. Like each people might have an idea of 50 to 20 50 to lot of people have those memory to store such many of contacts. But when we slowly adapted with respect to mobile and storing the contacts within the mobile, we are losing that memory power because of we have adapted towards the technology and we are using our mind or the brain towards other things. In similar way or similar fashion, AI is giving lot of technical advantages beyond the designers, and even sometimes it was far better than the super senior designers. But we should use that as an advantage, and we should use the AI to learn or to grab the knowledge very quickly, and we should mostly focus on the problem solving skills rather than the regular works. So such kind of regular works or any road blockers or reviewers can be given to AI and fast our work, and any problem solving skills or otherwise kind of major architecture design, such things need to be taken care by the engineers. That's what I believe, man. If you have any other doubts related to today, we can discuss on that front. Or otherwise, Surya, you can take it.
Yeah, thank you, Shankar. So that's it for today's session, guys. So recording sessions and your learning resources will be shared by your mail. Please check your mail. Please update it with your mails. And one more announcement. Yesterday, I have discussed that as a part of our fourth anniversary celebrations, every year we are organizing scholarship exam. So this year also we are going to organize scholarship exam 2026 national in a national level with which costs with worth 1.5 lakh prize money and internship opportunities in our company. So soon we are going to launch that scholarship exam 26 by this weekend. So we are requesting every faculty to share the info with your students to get benefited. So if you have any further doubts, Shankar is here. Or else, if you don't have any doubts, we'll wind up the session here. And the feedback link will be shared through WhatsApp. And coming to your attendance is also auto tracked. That's it for today, guys. If you have any queries or questions, please post here. If no questions, feedback link will be shared through WhatsApp by the end of the day.
Sir, I have one doubt, sir. Regarding that scholarship test, is any
Yes,
link
yes. Yeah, sir. So by this weekend we are going to launch. So after launching the postal, after launching our scholarship exam, we'll share the information regarding the registration link and poster in groups and in person also.
for
Sorry, sir, you're not audible.
the
Sir, your voice is breaking. Diploma students are eligible for test.
registration for the student might
No
have
registration. Sir, sorry, sir, you're not audible, sir.
registration link.
Yeah,
Why?
please.
Because you put it in the registration link, then we share it to our students.
Yes, sir.
So they
Registration link
easily
will be
register
shared
for
by
the
this end
scholarship
of the
exam.
week. Yeah. Sure.
Okay, sir.
Soon will be shared. Soon the link, registration link will be shared by this weekend because we are going
Okay.
to launch the scholarship exam on 24th January. So soon
Okay.
we'll share the link and the info.
Okay. Okay.
Yeah. So feedback link will be shared through WhatsApp in person. So it will be get by in person, not in group. Thank you so much. Fine. We'll wind up the session here. Thank you, Shankar. for your wonderful session. Thank you, guys. I'm not there in the WhatsApp group. Sir, please, I'm sharing the WhatsApp group link in chat box. Just give me a second, sir. Yeah, if anyone is not there in the WhatsApp group, please join. And we are like at present we are conducting only for engineering first year, second year, and third year students. Currently, diploma students are not eligible for the test. Yeah. Thank you. We'll wind up the session here. Thank you so much. Bye bye. Have a nice day. We'll meet again tomorrow.